All right, 8.3, applying accumulation of integrals. This should be pretty quick. It's kind of stuff we already know how to do. The issue is you're going to get, again, a lot of word problems, especially if you're taking the AP exam. You're going to get word problems. You do need to know how to read them and how to set things up correctly. So, when you're integrating a rate, okay, so again, if your function is a rate function, when you're integrating a rate, you are going to get net change, which again, we kind of talked about this before because we have said in the previous notes that if we're integrating our velocity function, what are we going to get? We are going to get displacement. Okay, so when we integrate a rate of change, we are going to get a net change. So, storm has washed away sand from beach, causing the edge of water to get closer to a nearby road. The rate at which the distance between the road and the edge of water was decreasing. That's an important term there, decreasing. During the storm is modeled by this function, feet per hour. T hours after the storm began, the edge of the water is 200 feet from the road when the storm began. If the storm lasted 4 hours, how far is the water from the road after the storm? Okay. So being from Florida and actually seeing roads being washed away after storms because, they're right next to the water, it was actually a pretty good question. So, now, first part, we are looking for the change, okay? Which means we need an initial value. Okay. What's our initial value? 200. So, 200. And since this is a rate that is decreasing, what are we going to do? We are going to subtract our integral. And since the storm lasted 4 hours, it is from 0 to 4. And again, I don't want to write the function out, so r of t dt. I keep writing f. R of t dt. All right. And again, on most of the time, you are going to have access to your calculator on the test. Okay. You're probably not going to be given this question, especially with this type of function, where you don't have a calculator, because doing the actual integral of this would be pretty crazy. Okay. So we're going to type this in our calculator. So we have 200 math integrate from 0 to 4 of a second. And that is negative sine x dx. Oh, I forgot the minus. There we go. If it'll work. Maybe it's... Oh, sorry. It's actually trying. I don't know if you can see this little tiny green circle here is thinking. So, as I said, trying to do this by hand would be pretty rough, and my calculator's taking its sweet time to get it done. So, anybody put that in your calculator? Give me an answer yet? Oh, there it is. Okay. So, yeah. Definitely a calculator question. So 196.937, and the units in this case are, since again we're changing this rate to a net change, the net change is distance, so that is feet. Now, this is a common FRQ part of, because FRQs are always multiple parts. Common FRQ question is just setting up the integral. Okay. So a store is having a 5-hour sale. The rate at which shoppers enter the store T hours after the sale is being modeled by the function E of T, which is measured as shoppers per hour. When the sale starts, there are already 70 shoppers in the store. So again, that's our initial value. We're going to start at 70. Write but do not solve an equation involving the integral to find the time x when the number of shoppers at the store is 200. Again, this should be a really simple question. It should be free points to everybody, because all you're going to do, since they only gave you this as a function, so you're going to integrate from the start of the sale at 0 to some time, which we don't know the time is. That's what we want to find. That is our x value. okay, of my function e of t dt. We want to know when this is equal to 200. Now, you do not even have to simplify this anymore. That is it. Now, don't worry, we will have an example of actually trying to do this in the next lesson, trying to find a value in the integral, okay, of one of our bounds. So, real fun question. All right, finishes up. Water is pumped into a tank at a rate modeled by RT liters per hour, or R is differentiable, and decreasing from 0 to 8. Select the values of R that are shown in the table at time t equals 0. There are 5,000 liters. Now, what this tells you, and this is what people often get this confused because, again, they're not quite reading the question, is this right here is the initial value. These are not amounts left in the tank. This is a rate. That is how much is being increased or decreased over that rate. So what does the integral from 0 to 8 of RT represent? Again, since RT is a rate, what does this represent? This represents the net change, or the amount of water left in the tank at no, over the 8-hour period. Now, again, you can phrase that however you like. Okay, you can say uh, from 0 to 8 hours, okay, on the interval from 0 to 8. Again, there's a lot of ways to write things in English. Okay. Now, again, this function is not saying that the amount is decreasing. What it's saying is that the rate is decreasing. So the amount that's being pumped into the tank is decreasing. So there's still water being pumped in the tank. The amount of water in the tank is actually increasing. It's just the amount that is being pumped in at each hour or at each point in time is less and less and less. So estimate using the left Riemann sum, because we can't do integration without, with a chart. So estimate with using left Riemann sum, which means we are looking at the change from the first interval from 0 to 1, that is 1. The amount of change on the left side is 3,000. Okay. Plus the change in the next interval from 1 to 3, that is 2. And the left side of that interval is 2,500. Now the net change is 3. The amount on the left side is 2,100. Plus, again, the net change from 6 to 8 is 2. And the left side is 1,500. Now, simplifying this, that gives you 3,000 plus 5,000, which is 8,000, plus 6,300, which is 14,300, plus 3,000, which is 17,300. Again, the amount is in, since this is about net change, whereas this is not any type of rate here, this is liters. Now, based on this estimate, how many liters of water are left in the tank? Again, this is how much was pumped into the tank. So we're going to take that initial amount of 5,000, given in the statement, plus the amount of change over those 8 hours to get 22,300 liters. Now, give me a second. another way to ask the same exact question, just differently. So same scenario, but this table, this is a table of the values that represent WT, the number of liters in the tank at a given time. So this is not a rate. But what does the integral from 0 to 8 of W prime of t represent? Because this function is not a rate, but W prime of t is a rate. This is the integral of a rate function, again, so it's the same answer. The amount of water in the tank at time, well, 0 to 8 hours. Really, we should say the amount of water pumped into the tank. Because again, it's about displacement, about net change. It's the amount of water pumped into the tank over those 8 hours. Now, in this case, if we were trying to find the integral from 0 to 8 of W prime of t, since we know that the integral of a rate function is just the antiderivative, that the integral from 0, well, integral from 0 to 8 of W prime of t is just W of 8 minus W of 0, which we have those values. 22 minus 5,000, that is 17,000 liters. So easy enough, even if you can't read my handwriting. All right, now this right here, this lesson is going to be kind of the basis for the rest of the lessons in this unit. Okay, everything else is going to require you to know this, which isn't really that bad. Okay, if we remember, we're doing integration. Let's say we have this function here, okay? If I want to know the area of the curve, I would take the integral of this function. I would find this area right here, okay? Now, if I had a separate function, and I want to know the area under this curve, that would be this area right here. But if I want to know the area between the curves, I want to know this area right here. What do you think we're going to have to do? What would you do if I want to know the area between these two curves? It's really simple. You find the two areas and subtract them. Okay, that's it. You find the two areas and you subtract them. Now, the quickest way, instead of having to find both integrals separately, okay, since we do know that if we take the larger integral of f of x minus the smaller integral, say g of x, that can be integrated into f of x minus g of x. Now, this is important to know, that f of x must always be greater than g of x. Okay? Again, where this value is a, here, and this value is b. Okay, we do need to actually find where they intersect. Okay, if I want to know the area between these curves, I will need to find where they intersect. Now, sometimes you are going to be given a specific interval. In those cases, you do need to make sure that one function is greater than the other function over that interval. That may come up later on. We'll see. Probably will. Okay. I hint at a little bit today. But that's going to be your big lesson. Sometimes they're nice. Sometimes they will give you the graph, and you can see that this is x squared plus 2, and this is y, y equals x squared 2, this is y equals negative x. We can easily see that on the interval from 0 to 1, this area right here, okay, which function is greater than the other? It's real nice when they give you that graph, because we can easily see which function is greater. Now, if you have a calculator, can you just graph them on a calculator and see which one's greater? Yeah, you can. That's perfectly fine. So we are going to integrate from 0 to 1. The greater function is x squared plus 2 minus the smaller function, which is negative x dx. So we get the integral from 0 to 1 of x squared. I'm just going to put this in order. Plus x, because minus and negative is positive, plus 2 dx. Well, this is easy enough to do. That gives you 1/3 x cubed plus 1/2 x squared plus 2x from 0 to 1. And nice thing is, if we plug in 0, the whole thing is 0, so I don't have to worry about 0. So just plugging in 1 gives you 1/3 plus 1/2 plus 2, okay, which gives you 2/6 plus 3/6 plus 12/6, which is 17/6. You're good. Okay. Yeah. Sometimes they're not so nice, and they don't give us the graph. Now, could we look at these and kind of decide, could we probably plot these and see which one's bigger? Yeah, those plots over here, and let's try using actual straight lines. Slightly better. So, negative x squared plus 2, that is going to look something like that. Okay. And y equals x is going to look like that. Okay. So we can see that we are going to integrate, okay, with the 2 minus x squared minus x dx. That's going to be our rule. But what do we not have? Yeah, we don't have the bounds. Okay. So to find the bounds, we are going to set these equal to each other because we need to know when these intersect. They intersect when they equal. So 2 minus x squared is equal to x. So I'm going to subtract both these over. 0 is equal to x squared plus x minus 2. 0 is equal to x minus 2 plus 2, x minus 1. So x equals negative 2 and 1. So negative 2 to 1 are my bounds. Now, again, if I didn't graph this, if you did not graph this, since we have our bounds now, we could just pick any number between our bounds, and then an easy number there is 0. If I plug in 0, which one has a greater value? Which function would be greater in value if I plug in 0? Well, this would be y equals 2, and this would be y equals 0. So this is the greater value. So that would go first. Again, it is important to know how, when you set these up, that you must choose the larger value first. Now, by the way, if you set this up the other way, what you're going to get is a negative area. Okay, and again, if we just put this in our calculator, because we can, math integral from -2 to 1. If we did set the other way, so we set up as x minus parentheses 2 minus x squared, we set up incorrectly, we get a negative area, negative 4.5. Okay, are we ever going to have a negative area? Should you ever have a negative area? No. Now, if you're looking for area between two, if I want to know if it was just one function and I wanted to know the area under a curve, okay, yeah, I could get a negative value there because it could be below the x-axis on some interval, okay? But when you're looking at area between two curves, you are never supposed to get a negative answer, which means really it's just going to be positive 4/5 because you just typed this in backwards. So if you change this and write this as 2 minus x squared minus x, you get the same answer but positive. So this equals, again, 4.5 is fine. You can write it as 9/2 if you want. I don't care which way you write that, but there it is. Now, this question is about just setting up the integral, okay? Because the problem here is I want to find this shaded area. Well, the greater function, that's pretty obvious. This right here is the greater function. Okay, so this is your f of x. Okay, this will be your g of x, except this was not always g of x. Okay, so my greater function, easy to determine. Right there, that's the greater function, y equals square root of x. But for the first part of this graph, up until 6, my lower function is just y equals 0. That's the bounds there. After that, I have the y equals x minus 6. So right here, I'm going to have to separate my integrals. Okay, I'm going to integrate from 0 to 6 of just the square root of x dx. Okay, there's no point in putting minus 0, because again, if you're subtracting y equals 0, it's just minus 0, which is nothing. Okay, plus the integral from 6 to wherever they intersect here, which is 9, of the square root of x minus the x minus 6 dx. Again, they don't want you to solve this, they just want you to set it up. On the homework, they may ask you to solve it, which again, you can just plug in your calculator. If you have a calculator, plug in your calculator. Again, practice doing this by hand, but always check with your calculator. All right. Now, on to the fun questions. Does everybody have a calculator? Because you're going to probably want to practice this. So if you don't have a calculator, I would come get a calculator. Right. All right. The reason why I say get a calculator is because, again, the title should be kind of obvious. Just beware of rounding errors. Okay. Again, we don't have the graph, but we can graph these. We have, again, natural log of x is real fun. We do know what the natural log of x looks like. Again, natural log of x looks something like this, where we know at 1 it is 0. Okay. And y equals 1/2 x squared minus 2 starts at -2, goes up half. Okay, I don't know where this is going to intersect at some point, but it's going to intersect somewhere way out there. I don't know exactly where. Okay, but that's what it looks like. So we do know that this is your f of x and this is your g of x. That's easy enough. Okay. What I don't know is where they intersect. And that's where that rounding error is going to come. So we are going to have to graph them no matter what. So we have, clear this, natural log of x, and we have, what was it, 1/2 x minus 2. So graph. Oh, I need to zoom out a little bit. There we go. All right. Now, you all know how to find where points intersect on your graph, right? Intersection between 2 points. On my calculator, unfortunately, I don't have the buttons that you guys have. So you are going to press what second calc or second trace and go to 5 where it says intersect. Okay. You're going to choose first function, choose second function. Now, when it says guess, and I have found out why it says guess, all right, because this intersects in 2 different locations, you need to put your little cursor closer to the intersection you're looking at. Okay. So if you say guess and you scroll all the way over to the right, it's going to give you that one right here. Okay. I can't write on this, but if you put your cursor somewhere over here, okay, so if you put your cursor over here, it'll give you that one. All right. So when it says guess, it's saying put the point closest to the point you want to find, and that's the value I'm looking for. Okay. Now mine, I could just press this button and I'd be done with it. Okay. Now here's the issue you're going to come across, and I'm going to have to. I don't know if I'm going to be able to do this on my calculator because it just gives me both. Um, so, and I wish I kind of had a regular calculator. Do I have one on my computer somewhere? Let me see if I do. GI. Oh, I do. See if it lets me on there. It does. Okay. So I'm going to bring this over here. Let's see. I need to see this here. View. No, it's going to be kind of hard to see, but we'll do our best we can. All right, so let's type this in here. So y, clear this. We have natural log x. All right. And we had what, 0.5x minus 2. All right, graph. Now, if you ever need to fix your calculator's screen, you can press zoom and go to standard, which is 6, I think. So it puts in that standard 10 by 10 frame. Well, 20 by 20 technically. So we are going to go to second calc. We are going to go to 5 where it says intersect. I'm going to choose my first. So this is the blue line. Choose that one. And then choose the red one. I should already be on the red one, so yeah. Now again, where it says guess, if I scrolled all the way over here, that would give me that upper function, that value right there. But I want to scroll back over here. I want the lower value first. So yes. All right. So it gives me some value that I cannot even see on my calculator. Okay, let me see if it says the correct value. Yeah, 0.145516 something, something, something. So it does give me that. It's kind of hard to see on there, but again, you have your own. You should be able to see that. Right. Does everybody have that first one? Because this is what I want you to be able to do. This is the kind of the point of the day. Something that you may be learning new today that your calculator can do. Okay, so my calculator just found an answer. It found a value. It calculated a value. what you can do is exit out of here, so press second quit, and you can store that answer as, I'm going to store it as A. So second, not second, alpha A. So I'm going to store that as A. And you should see that value pop up. So now I don't have to worry about writing the value down. I don't even have to worry about rounding because this is what my calculator shows me, but my calculator actually stores the entire value, a much larger decimal place than what it even shows. So I can use this in my integration without having to round at all. Again, I had a college professor. He taught my Cal 3, my differential equation class. He loved to say, the more you round, the more you're wrong. Okay? So if you have to do any rounding, don't until you're done. Never round until the final answer. All right? So we're going to do that. We're going to go back to my graph. I'm going to find my next intersection. So second calc, second trace. 5 again. And then I'm going to, again, it doesn't really matter if you choose, you just need one function and then the other, but you need to scroll over to the point where it wants you to guess. So I'm going to scroll all the way over here, closer to this point. So there it is, and then enter. And again, I can't see what that says, so I'm going to move that over to make sure it's right. So you got 8.210933 something. So yeah, so I'm going to go back out of here, and I'm going to store that now. Second quit. So I'm going to store my new value as alpha b. So now the nice thing is I've done a lot of work in the calculator already. So when I want to integrate the two, right, I'm going to go to math, down to what, 9? Okay, to integrate, I'm going to go alpha A up to alpha B. And then your variable, if you remember your variables, y variables. So this is variables. Go to y variables. You want to use your function, so press enter. And I'm going to do my first function because that was my natural log. So enter, or 1, minus, go back to variables, y variables, enter, number 2 here. And then scroll over to make sure it's dx. Now it's going to take a moment to calculate. But yeah, there it is. Okay. So we get, again, on our screen here, just to show all that work, we get we stored alpha A as what? 0.14555516, whatever that is. B was 8.210933, whatever that is. And then we integrated from A to B, y1 minus y2 dx. And we got 8.784. We only round at the very end. Now again, if we had rounded at all, let's say I did this while you're writing this down. Math, integrate. I have my value of 0.146 and 8.211 of, what was it, the natural log of x minus 0.5x minus 2. Was I that off? No. Wasn't that off to begin with. Okay, would have got the same exact answer. All right, but doesn't mean it'll always be that way. Okay, let me see. What was the actual answer? How far was I off between the two? Let's see, because I can't really see that. 8.7181748. It was really close. It really wasn't that bad. All right. But do be careful because of rounding issues. All right. Especially if you're given questions like this, I would definitely use your calculator to do all that work for you. One, it does save you a ton of writing. Okay. So instead of having to write all that down and type it in, you can just use your calculator to do all that work for you. So there it is. Then on to the best question of the day. Let R be a region bounded by the two graphs where this is y equals 2 squared of x. This is y equals x squared over 4. Okay. We want to find the line x equals k. So we want to find a vertical line that's going to bisect this region into two equal parts. I want to know what the value of k is. So we're going to just draw up a little pretend line right here. Let's move it over a little bit so we don't see it exactly as 2. So we want to find some value k that's going to separate these into two equal parts. Now, if you remember that this is about the integral of the larger bound minus the smaller bound over the boundaries, well, this initial bound is 0, and here we have k, and then we have another boundary of 4. We want to know when the integral from 0 to k is equal to the integral from k to 4. That's what we want to know, and we'd have to find what k value gives us that. So, setting up the integral from 0 to k of 2 squared of x, because that's a large function, minus x squared over 4. When is that, again, dx, when is that equal to k to 4 of 2 squared of x minus x squared over 4 dx? Now, if you remember, what's the integral from the square root of x? Okay, this is 2x to 1 half. If we add 1, we divide by 3 halves. So you end up with 2x to the 3 halves times its reciprocal, 2 thirds. All right. Again, add 1, divide by 3 gives you x cubed over 12. On the integral from 0 to k, when is that equal to the, again, the nice thing is it's the same exact function. So 2x to the 3 halves times 2 thirds minus x cubed over 12 from k to 4 this time. Now we can simplify it a little bit. If I plug in k, well, 2 times 2 thirds is 4 thirds k to the 3 halves minus k cubed over 12. If I plug in 0, I get 0, so it doesn't do anything. Plugging in 4, I get 4 thirds times 4 to the 3 halves minus, well, 4 cubed is 64 over 12 minus, well, the 4 thirds k to the 3 halves minus k cubed over 12. Now, I do want to get k on one side, so I'm going to add this over, which basically just doubles this value. So if you just add, when you add this over, it's going to double this, giving you 8 thirds k to the 3 halves minus, if I double this value, I get k to the third over 6. Simplifying this, 4, the square root of 4 is 2, 2 cubed is 8, 8 times 4 is 32 over 3. And you actually don't need to simplify this anymore, okay, because we're going to have our calculator do this work for us. So we're going to plug these in our graph. and see where they intersect. So 8/3 x, just as a fraction, second fraction. 8/3 x to the 1.5 minus x cubed over 6. And then again, you don't have to simplify this. You can just type it in as it is. 32 divided by 3 minus 64 divided by 12. And that's not 32. There you go. So again, you don't actually have to simplify that at all. You can just type it in because it'll do the work for you when you graph. And there it is. Now, we do have two answers. We should only have one. Which answer is not, or which of these intersections is not part of our answer? First or the second? Think about what this is asking. Where is k in between? K is in between 0 and 4. That second value is definitely out near between 5 and 6. So this value, whatever this value is over here, which again I can't see in my calculator, but that second value right here is not helpful. So just the first. So I'm going to find that first intersection. Again, you can use your calculator to do the intersection for you. But we get k is equal to 1.764. Because that is between 0 and 4. All right, that is it today. Should be, because you only had like a minute left in class. So, the homework done. I will post the answer keys. Just a second.